Hi, so in today's lesson, we are going to embark on slope and equations of tangent lines. So thus far we have studied the slope, and we have even studied how to kind of get an approximate slope of a tangent line. But today I'm going to connect that with limits. Okay? So let's take a look at what this first paragraph says. It says, suppose we wish to find the slope of the line tangent to the graph of f of x equals x squared. That's our parabola. Okay? At the point 2, 4. The graph of f is shown at the right along with its tangent line at 2, 4. As we know, it takes 2 points to find a slope, and we only have the point 2, 4. As we know it takes 2 points for this. So anyway, thus we will approximate the slope by using a secant line. All right? So basically, we're just going to kind of get close. It doesn't look like we're entirely close. It looks 2, 4, 6. This looks maybe like it's at 6 squared, 636, I guess. But let's just call this point x comma f of x. And this is what we're doing here. We have one point, 2, 4, and another point, x comma f of x. Now, in our problem, x f of x is actually x squared. Okay, so that's no different. So I could have labeled this point right here, I could have labeled it x comma x squared. But whatever the function is, I'm trying to have some notation to where you will, so that you can use it for any function, not just this x squared function. So let's take a look at this one. So the slope of this secant line would be, f of x minus 4, y2 minus y1 over x2 minus x1, so x minus 2, right? So let's try to use this idea, so anyway, let's start using this idea. Now this could have been x squared minus 4, but let's leave it as f of x right now. So this says to find the slope of the secant when x equals 3, when x equals, I'm going to make a minor correction, 2.5, 2.1, 2.01, and 2.001. So what I've done is I've filled in the chart a little bit, and this would be 3, and then when I substitute in 3, I'd get 3 squared, or 9. When I substitute in 2.5, I would get 2.5 squared, or 6.25. So those are all of our points. And basically what I'm doing is I've chosen 3 comma 9. So let's say this point's right here. And then what I did was I did 2.5, so I'm getting closer. And then I did 2.1, so I'm very close now. And then I'm doing 2.01, very, very close. And what you'll notice is that what I'm going to eventually get is some kind of value of the slope right at that point. All right, and you can kind of see how that slope, it's actually decreasing. It's a decreasing slope, right? As I'm getting closer and closer to that x equals 2 value. So, all right, so let's start on computing this slope. So if I were to compute this slope, wouldn't it be something like f of 9 minus 4 over 9 minus 2 by using that formula here on the right? So what we're going to do is we're going to jump over to a TI-84. So go ahead and get that out for me. All right, so now that you've grabbed your calculator, let's go ahead and type in that y equals. And what we're going to do is, you know what? I'm going to do this problem here. Yeah, we're going to type in x squared right there. We'll go back to the home screen, and we're just going to type in this slope formula. So alpha y equals will get you that fraction bar. And alpha f4 will get you y1. So we need to do y1 of 3 minus 4 over 3 minus 2. All right, so hopefully that's not totally against your train of thought. Now, I did mess up a little bit here. This should be a 3 then, f of 3 minus 4, and then f of 3, I'm sorry, just 3 minus 2. Okay, so we'll type that in, we'll push enter, and we are getting an approximation of 5. All right, so we're going to do that same exact process. So we're going to use that same thing here, but instead of 3 this time, we're going to be using 2, insert 2.5, all right? So 2, and then I'm going to insert a 0.5. So 2.5, and this time I'm getting 4.5. Okay, so you can see as we're, so that first one it had a slope of 5, but then the next one had a slope of 4.5. So it's kind of decreasing. The slope itself is decreasing as I'm going towards that point from the right, right? Okay, so we'll go ahead and change that 2.5. We'll change it to a 2.1. And now I'm getting 4.1. All right. And instead of 2.1, what if I typed in 2.01? You're seeing 4.01 now. Okay, I'm getting a pretty good guess on what I think the slope might be exactly, right? So I'm going to insert another 0 there. Second insert. I'll get you that. And now I'm getting this 4.001. Okay. So, So what do you guys think that the slope is at the point 2, 4? So the slope at 2, 4 is 4. And by calculus, I'm telling you, yes, it is exactly 4. But you don't really know that quite yet. So let's continue talking through, and let's actually learn the limiting process real quick. So here are some problems that you can do where you can kind of learn the limiting process. Now the limiting process, here's what I'm saying, is use this limiting process to estimate the slope at x equals 0.7. So this first point, this would be 0.7 comma f of 0.7, or you can think 0.49. I don't know how you want to think of that, but let's consider this point right here. And then we're going to go out to 0.6 and to 0.65 and to 0.69. So we're going to get closer and closer to that 0.7, and we'll see what that slope ends up being. All right, so I'll do this one more time. So I still have my x squared function, and I still have these entries that I've made before. Let's see. If the first point, let me see. If the first point is 0.7 and f of 0.7, then our other point would be this 0.6 and 0.36. So I'm finding the slope of that. So let me see. Alpha y equals, and what we're going to do is say y1 at 0.7 minus y1 at 0.6, sorry, insert that parentheses, all over 0.7 minus 0.6. All right? Okay, so the last time I had a 4 right there instead of this y1 at 0.6, but it was y1 at 2. Okay, so if I wanted to rewrite this, and maybe that would have been easier, f of x minus f of 2 over x minus 2. All right, so maybe that does make a bit more sense. Okay, so if I shoot the video again, that's what I'll do. All right, so here we go. So we're going to type that in, we push enter, and we get 1.3. So 1.3 is my first slope. I go back here again, but instead of using 0.6, I want to use 0.65. So I'm getting closer to our 0.7 that we want to get to. So it looks like this time the slope increased by a little bit. And 0.65, well, that is going to change into 0.69. And now I'm getting 1.39. And I do that again. But this time, instead of 0.69, it's 0.6999. Okay? Oops, that's a parentheses. 999. All right. So that's 1.399. And I bet the next answer is just going to have more nines, right? So if I did 0.699, there's 4 nines this time. We'll go in there, insert another 9. 1.39999. So at 0.7, the slope of the secant line, or the slope of the tangent line, because we're approximating the tangent line, is 1.4. All right, so take a few minutes and do those next two. I'm not going to record that part though, okay? So go ahead and take a couple minutes and do those. So for the second table, this is what I recorded. Using the same logic as the last table, I have 2.5 and it gets all the way close to 2.5999. So I'm estimating that that the tangent slope is probably at 2.6 when the x value is at 1.3. So again, take another minute and fill in that next table if you haven't done so already. Okay, so the last table, I substituted in the values into the slope formula. I'll show them here. Okay, so I substituted those in and I got this table 2.9 and it got closer and closer and closer, it looks like, to 3. So at x equals 1.5, my tangent line would have a slope of 3. Now, how does the slope relate to its corresponding x value? Well, 0.7 and then 1.4, 1.3, 2.6, 1.5, and 3. Oh my goodness, it's just multiplied by 2, right? Multiply by 2. By 2. So that's kind of an exciting result, but the limiting process itself can be exhausting, right? So what we're going to do is we're actually going to do something different. We're not actually going to use the limiting process past these notes. Because, why not? Basically because of entertainment value, folks. That was hard. You don't want to have to do the limiting process. So I show you the limiting process so that I can actually show you a limit. So using limits actually allows for a much less cumbersome approach to finding the equation of the slope of the tangent line. So let me show you that in the next page. So what we're going to do in order to find the slope of a tangent line, in our example, we simply just take the limit as x approaches 2 of the equation of the secant, right? Now what was that equation? Well, it's the limit as x approaches 2. I think it was x squared minus 4 over x minus 2. And remember, if we substituted in a 0 there, a 2 there, then we would get indeterminate form, which tells us that we need to factor. We need to rewrite this equation, this expression, as an equivalent expression. So we'll write the x plus 2 and x minus 2 on top by factoring, x minus 2 on bottom, and you can see that the x minus 2's can cancel out. Once they've canceled out, feel free to go ahead and drop the 2 in where it belongs, and you'll see that your final answer is 4. So that was a lot easier than approximating, right? Remember what we had to do with the limiting process. We had to plug in values closer and closer and closer to 4 and we got the slope was closer and closer to 2, and we got the slope was 4, but that was a lot of calculating. All right, so we just use the limit. So thus, the exact value for the slope of the tangent line at x equals 2 is 4. So we are super happy about that. All right, so these notes are continued, but it would make the video too long. So what I want you to do is, if you want to continue the study, go ahead and find the next page of notes and work through those. So I've done my best to try and share with you guys slope and equations of tangent lines, and I hope you appreciate the video. So take care, give me a thumbs up. All right, later.